Hello everyone, I'm going to talk about mixtures and their different types. Mixtures are combinations of two or more substances that are physically combined, not chemically. We generally categorize them into two main types, homogeneous mixtures and heterogeneous mixtures. First, let's talk about homogeneous mixtures. A homogeneous mixture is a mixture that has a uniform composition. This means that the components of the mixture are evenly distributed, and it appears the same throughout as it has a single phase, and you cannot distinguish the individual components with the naked eye. A solution is a homogeneous mixture of two or more substances which consists of two main parts, the solvent and the solute. The solvent is the dissolving medium and the solute is the substance that dissolves. In the solution, the solute particles are so small they range from 0.01 to 1 nanometer in diameter. That's why they cannot be seen and they remain mixed with the solvent. Also, they cannot be separated by filtration. Solutions can exist in various states of matter, depending on the states of the solute and solvent. Here are the types of solutions according to the solute-solvent combinations. The first type is the gas and gas solution. In this solution, both the solute and solvent are gases. An example for this is the air. In the air we have oxygen, nitrogen, and many other gases mixed together. The next type is the gas and liquid solution. In this solution, a gas is dissolved in a liquid. Examples for this are the soda drinks. In these drinks, carbon dioxide is dissolved in water under pressure. The next type is the liquid and liquid solution. In this solution, two liquids are mixed. An example for this is the wine. In this drink, alcohol is dissolved in water. The next type is the solid and liquid solution. In this solution, a solid is dissolved in a liquid. An example for this is the salt solution where salt is dissolved in water. Next, the solid and solid solution. In this solution, two or more solids are melted and mixed, then allowed to solidify. These are also known as alloys. Now let's talk about heterogeneous mixtures. A heterogeneous mixture is a mixture that does not have a uniform composition. This means that the components of the mixture are not evenly distributed, and you can often see the different components. In these mixtures, different parts of the mixture have different properties, so they have multiple phases. Heterogeneous mixtures are divided into two main types, suspensions and colloids. First, let's talk about suspensions. Suspensions are heterogeneous mixtures where the solid particles do not dissolve in a liquid substance. Particles are relatively large as they are over 1000 nanometer in diameter, and they can settle out over time even after stirring or agitating. An example for this is the muddy water, where the mud settles down over time. Now let's talk about colloids. Particles larger than those in solutions but smaller than those in suspensions form the colloids. These particles range from 1 to 1000 nanometers in diameter. They do not settle out. Instead, they are suspended throughout the solution, making up the dispersed phase, and the liquid is the dispersing medium. Even though colloids are heterogeneous mixtures, they often appear homogeneous. So how can we differentiate between the solutions and colloids? The Tyndall Effect is an easy way of determining whether a seemingly homogeneous mixture is a colloid or a solution. It is the scattering of light by particles in a colloid. When a beam of light is shined through a colloid, the light does not pass. Instead, the particles disperse the light in various directions, making the beam visible. While in solutions, the light passes straight through. The size of the dispersed particles is the main factor determining if a mixture is a solution, colloid, or suspension, and if the Tyndall effect will be present. Let's visualize the Tyndall effect. First, we have a glass of water, and then we will add a spoon of table salt to the water. Then we have another glass of water and we will add some milk to it. Next, we direct a flashlight to the mixture of salt and water. As you can see, the light passes straightly through the mixture. This shows that the mixture of salt and water is a solution. After that, we direct the flashlight through the milk and water mixture. You will notice that the light does not pass through the mixture, and the mixture is glowing. This shows that the milk and water mixture is a colloid. That's it. Thanks for watching.